Hello, Cold Harbor Cougars and families. Welcome to the second math video for week 6. I am here to talk to you about how you can represent numbers in different ways. So hopefully you just finished the quick place value review that Ms. Gibaldi worked on with you guys, and you're ready to dive into our next math skill for this week. If you take a look at the parent materials guide for this week, you'll notice that there is a link here for an activity. And that link is going to take you here to this page. You're going to want to watch this video to see some practice examples done for you before you come back to this sheet. I will say there's not a lot of space on this piece of paper to complete the activity, or you're going to need to draw models to build numbers in 2 different ways. So you may want to use a scrap piece of paper or the back of your page if you do have the printed version of the packet. All right, so let's go ahead and switch gears and start looking at how we can represent numbers in multiple ways and why it's important for us to be able to do that. And getting started with our conversation about representing numbers in different ways, I do just want to draw your attention to the notes that I believe Ms. Gibaldi talked to you about as well. Page 3 of the notes that we've shared for the start of this place value review unit really dives into the concept that I'm going to be talking about today. And we'll see if it'll load here in just a second. All right, so I'm scrolling here down to the representing number section. This is going to be a great reference tool for you all to use while you are working on the activity for this part of the math lesson. Essentially, these notes are just depicting some of the different ways that you can represent numbers. So let's take a look at the very first example here, because it's a great basic representation of how we can represent a number in a lot of different ways using place value blocks. So we have a number here, 50, and we've represented it in 1, 2, 3 different ways. No matter the different way that we build this number, the value will always be 50. So we could build that with 5 tens. So we have 5 rods here. That equals 50. We could build that number with 50 ones, which you can see here. We have 50 ones blocks all together in a group, and that value is 50. The third representation is where it gets a little more exciting. You can see that we have a mix of rods and single blocks. We have 3 rods, so we know that that's going to equal 30, which you can see right here. And then we have 20 ones blocks, which of course has a value of 20. So when you add the value of 30 and 20 together, you have the value of 50. So whether it's 3 rods and 20 ones, 50 ones, or 5 rods or 5 tens, the value of each of these pictures is 50. And that's the real base of the skill that we're going to be working on today. So let's jump and look at some more concrete place value block examples. Alrighty, let's jump into a little more practice. We just looked at an example with the number 50 and the different ways that we could represent that simple number using our place value blocks. We're going to kick it up a notch and look at a number like 236. Whenever we're building a number with place value blocks, we typically try and build it with as few blocks as possible, which is what I've done here in this first example. And I've really taken a look at the digits in those place value positions in order to determine what place value blocks I need to use to build this number. So with a 6 in the ones place, I know that I just need 6 ones. With a 3 in the tens place, I know that I need 3 tens. With a 2 in the hundreds place, I know that I need 2 hundreds flats. And so just to make sure that all of my math is correct, I'm going to go ahead and identify how many of each place value position I have, and then use my expanded form to check my work. I see 6 ones here. I just spent a couple lines. I see 3 tens. Excuse that terrible 3. And I see 2 hundreds. Now, if I were to write that in expanded form, I know that 2 hundreds is the same as 200. I know that 3 tens is the same as 30. And I know that 6 ones is the same as 6. So if I add up 200 plus 30 plus 6, I get that original number. Now, I can represent 236 in countless ways, and I'm going to show you one way you can change your representation and check your work. One really easy way to change your representation is to just make a trade. Just like we learned with regrouping, we can make a trade with our place value blocks. Let's take a look at our rod, for example. I know that each of my rods is the same as 10 of these blue blocks. So I'm going to go ahead and remove one of my tens rods, and I'm going to replace it with 10 blue ones blocks. So now, instead of 3 tens, I have 2 tens, which is the same as 20. And instead of 6 ones, I now have 16 ones, which is the same as adding 16. So yes, now my numbers look different, and so does my representation. But when I add all of these parts together, I'm still going to get 236. Because I know that 200 plus 20 is 220. And if I add 16 more to 220, I'm going to get 236. So that was one really simple way I could adjust my representation to still match that original number. So instead of 3 tens, I now have 2. Instead of 6 ones, I now have 16. Let's say I want to change it up again and show a third way to represent the number 236. There's another swap I could make based on what I see on my board. I'm going to go ahead and swap one of my hundreds blocks out. And I need to know how many tens rods I need to put on my board to replace this hundreds flat. You guys have any ideas? Take a second to think about it. All right, if you said that one flat that represents 100 is the same as 10 new tens rods, then you were correct. Now I'm leaving those original 2 there, and I've replaced one of my flats with 10 new rods. Now I need to make sure that my numbers up here reflect that change. So instead of just 100s flat, or instead of 200s flats, I now have 100s flat, which means I only have 100 right here. Instead of 2 tens, I now have, that's 10 right here, 11, 12. I have 12 tens, and I need to figure out how much that equals, so I can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. All right. Did I change anything with my ones over here this time? No. So I can leave 16 by itself. So now I have 100 flat, 12 tens rods, and 16 ones, which is the same as 100 plus 120 plus 16. So when I add 100 plus 120, I get 220 plus 16, which brings me back to my number 236. So that's 3 different ways that we can represent the number 236. Let's take a look at another example. Our new number is 429. Just like we did the last time, the first way that I'm going to represent this number is with as few blocks as possible. And I'm going to make sure to use what the number is telling me to help me do that. All right, so looking at our place value positions, I see a 9 in the ones place, so I know that I need to have 9 ones. There's 7, 8, 9. I see because there's a 2 in the tens place, I'm going to need 2 tens or 2 rods. I'm going to go ahead and put those there. Then I see that there's a 4 in the hundreds place. So if there are 4 hundreds, that means I need to have 4 flats on my board. You can see here I have 1, 2, 3, 4. All right, so now I can think about my expanded form to make sure that what I have on my board does truly represent the number here at the top. So I see 4 hundreds, so that's going to equal 100, 200, 300, 400. All right, I'm going to add my tens to that. So if I have 2 tens, I know that's 10, 20. So 400 plus 20. And then if I have 9 ones, I know that that's the value of 9. So 400 plus 20 plus 9 does in fact match 429. Just like we did with our previous number, I can represent this in a different way. And one of those ways I can do that is by making a trade, okay? So I'm gonna stick to what I practiced last time, and I'm gonna swap out one of my rods for some ones. And I know that each of these rods represents 10 of my blue ones blocks. All right, so I'm adding, there's 5 more. I need to keep adding more to that. So here's 5 more. So I just added 10 ones blocks to my representation because I traded one of my 10s out. So instead of 2 10s, I now have 1 10, and I know that 1 10 represents 10. Now I no longer have just 9 ones, I added 10 more to that pile. So instead of 9 ones, I now have 19. So I need to make sure that the value in my expanded form matches that as well. So I have 400 plus 10, 410 plus 19 is going to give me 429. So again, though my model looks different from how I started, the value of that model is still 429. Let's take a look at another way we might see a different type of representation for a number. I have a number built here on my board, but you'll notice I don't have what that value is. So it's going to be our job to take a look at the model that I've created in order to determine its value. All right, so one thing that I can do, the first way we're going to look at it, is to just identify how many of each type of block I have. So I might start here with my ones. And I see that I could count it by 3s going this way, or I could count it by 4s. So I have 3, 6, 9, 12. All right, I have 12 ones. Let's look at how many 10s I have. 1, 2, 3, 4, 5, 6. I have 6 10s. And I have 200s. Now I'm going to think about that expanded form to help me figure out what this number is. So if I have 200s, I know that that has a value of 200. I know that 6 10s has a value of 60. And 12 ones has a value of 12. So I have 200 plus 60 plus 12. I might try and combine my 60 and my 12 to see what that adds up to, or what my sum is. So I have 60 plus 12. That's going to give me 72. Then I have 200 plus the 72. And that's going to give me my final value of 272. That's one way that you can approach a question like this. But I bet some of you had some red flags going off as soon as we realized that we had 12 in the ones place. Because I know you all know that we cannot have 12 in the ones place. So that leads me to the other way that we could take a look at this problem. So I've erased all the work that we just did, but we'll keep in mind that we got 272. Whenever I have a number in a place value position that's more than 9, like for example, here I have 12, I know that I should be thinking about regrouping or trading my blocks for the next block. Because I have more than 9 here, I know that I could have another rod. So I need to think about how many of these I need to trade or regroup to make a rod. I know that a rod is worth 10, so I'm going to remove 10 of these blocks. As you can see, I just did like that. I counted 4 plus 2, that makes 10. I'm going to take those 10 blocks away and replace it with a rod. So now when I represent my number, I see that I have 2 ones. I'm comfortable with that number. Let's take a look at our 10s now. 1, 2, 3, 4, 5, 6, 7. 7 tens. And I have 2 hundreds. So each of these numbers are good numbers to have in a place value position. So now I can think about that expanded form. If I have 2 hundreds, I know that has a value of 200. If I have 7 tens, I know that's a value of 70. And if I have 2 ones, I know that that is a value of 2. So when I add that expanded form together, I have a value of 272, which matches exactly what we had on the board before, just represented differently. The value of both of those models was 272, but shown in 2 different ways.